everything good. So today I'm going to talk about the user study, and then we're going to talk about what is the actual user experiment, and then usability testing if possible. Because today's lecture will cover many things, so hopefully I wanted to cover usability testing as well, but there is a depend on the time. And then lastly, we will see together the case study. Have you read the paper? Who actually read the paper?
Started to write in computer.
Okay, great. Okay, great. Yeah. So today we will pass the actual paper. Actually, the paper is a pretty good paper, so maybe you can get some knowledge how actually we can write user experiment, and actually we can write the scientific report, so which is really good. As a just a reminder, this is the last time we have seen this slide. This is a user study method. The method will cover observation, ethnography, and the case study, interview, focus group, survey, questionnaire, and the usability testing, and the user experiment. Is there anyone who can distinguish what is the actual difference between the user study and the usability testing? What is the actual difference?
User study is studying people, and usability testing is when you're actually testing the product on people.
Yeah, kind of that. And then actually that slide shows that what is the actual difference. Sometimes people have some confusion what the terminology when they use user study or usability testing or user experiment. But as you see there, usability testing and the user experiment is just one of a method what for the user study. So user study is a much broad term, and there is a higher hierarchy. And then under the user study, we can sometimes we depend on our experiment design. We can use a usability testing method or observation method or user experiment method. But the difference, the critical difference is, as you see there, user experiment is a much experimental investigation, which means there is a much scientific report, scientific way. On the other hand, the five of them is a much descriptive way. So which means is when we just observe something behavior or something phenomenon, then we just describe it. Sometimes it is a lack of the objective measurements. So user study. The user study is an investigation of the user and the user with human-computer interface. So it have to be explained, and it have to be very concise, and it have to be predictive. So user study is a main method which used in human-computer interaction field, and then there is a very closely related to other academia like behavior science in psychology or ergonomics or human factor. And then this is just an example, so that is not limited only those academic area, but also relate to education or computer science, even sometimes physics as well. So just to quickly talk about that one. So there's three types of research or investigation method. One is a descriptive investigation. The other one is a relational investigation. And then last one is the experimental investigation. So actually our focus is the experimental investigation. That is a causal relationship. So we wanted to find something causal relationship. So last time we have talked about that one. This graph, this table shows very clearly what is the difference between among the descriptive, relational, and the experimental method in research. Also, we remember that as a object measurement. Give me 1 second. Yeah, this is much better. So we can measure completion time or error ratio or percentage or number of repetition, and the physiological data that is a heart rate or maybe GSR or something. What else? Our pulse rate. That is a physiological signal, so we can collect the data as an objective way, and then orientation, position, our body movement as well, and the scores and something action and the running time, retention rate. All of these measurements can be regarded as an objective measurement. On the other hand, those type of measurement is the subjective measures, rating, ranking, and using the surveys, usefulness, ease of use, ease of learning, and the naturalness, presence, those kind of items, we regard them as subjective measures. So because several times I repeatedly focused on what is your research question, then what is your measurement. The reason is those are basic fundamental way, but many people miss the mention about these items. So this is a really important one. Okay, so let's talk about the user experiment, and then if possible, let's talk about the usability testings as well. So because user experiment is our way, we wanted to find something scientific knowledge, right? So we may want to choose a user experiment for your future thesis as well. And then the user experiment is a method of academia research in HCI. We talked about that. And then we wanted to find something scientific knowledge. So we want to find discover or testing or approve new knowledge. This is the main difference compared to the usability testing. Actually, the usability testing is much focused on engineering perspective, which means they don't care about the finding new knowledge, but they wanted to improve the user performance, find something good way in terms of user interface. So that is a big difference. So we always begin with a research question, right? So we have a research question. Last time, 8 people sent the first assignment, which was really good. I'm gonna share the idea on it. I don't disclose your names, so that's fine. But the problem is sometimes the research question was good, but sometimes the research question still very vague. So we want to have a very clear research question, and the research question can be and it should be represented with a clear hypothesis, right? And then your research, the user experiment should be replicable. Last time we talked about that if some research cannot be replicable, which means it is useless. So because the user experiment wants to find a new knowledge, and the new knowledge have to be generalized, which means it have to be replicable. Once you get some result, and then you withdraw the conclusion with a statistical test of the hypothesis. So usability testing or user experiment, the both way can use same method, like observation, key logging, lab setting, usability questionnaire, quantitative measurement. We can share those methods. It is not a matter. But as I mentioned before, the goal is very different. Usability testing focused on the improving its performance from the engineering perspective. On the other hand, user experiment wanted to find something new knowledge. So the goal is answering about the research question. So without the research question, the result, we can't get any result actually. So this is the table. What is the actual difference between the usability testing experimental study? Let's see the experimental study size first. So we wanted to discover knowledge, and then it requires many participants. The interesting thing is actually when you're doing the usability testing, then you sometimes, that is depend on the situation, but basically you may don't need a large number of participants. Somehow 5 experts will be enough. because there is some research, and the research says that only 5 experts will can discover over 80% of problems, which means if we have only 5 experts, and if we ask them to testing my product, then they will find about 80% of problems, so which is fine. But that is only depend on the situation. On the other hand, when we doing experiment study, we generally require many number of participants. We will have another session maybe 4 weeks or 5 weeks later. Then we will talk about how we can decide the actual number of participants. Okay, so the result should be validated statistical way. So we will talk about the stats 3 weeks later, and then the experiment should be replicable, which means we want to find some generalized result. And then when we doing the experimental study, the environment should be controlled very strongly. And then we are doing the experimental design, and then the result should be reported to scientific communities. On the other hand, when we're doing the usability testing, the goal is just improving its product performance. So it doesn't require many number of participants, and the result have to how to design the certain product, and usually it does not completely replicable. So sometimes depending on the situation, they just only focused on this case or this case or this case, so it doesn't matter. Also, it required to have a controlled environment, but that is not strongly recommended. So that is much flexible, and then procedure is always planned, and that the result report to product designer or developers, not to scientific communities. That is the main difference. So this is the way how we set our user experiment. So the first thing is set your research question, which means you may want to make your hypothesis. After that, you will make some specific task. So you will assign certain specific task to each participant under different condition. So that is depend on how you're gonna design your experiment design. We will talk it a little bit later, but you may choose a between subject test or within subject test, or you may choose multifactorial subjective test. During the test, you may want to collect a certain qualitative or quantitative data. After then, you will analyze the collected data. After then, you will answer to the research question depend on your result. Have you heard about the independent variable and the dependent variables before? Okay, so what is the independent variable, maybe? Can you?
The independent variable is the one that doesn't change?
Yes, which means that is an actual factor. For example, you wanted to have a comparison about the pointing time. So in the case, you may want to use just a touchpad, and then maybe wanted to use a mouse. So you wanted to have a comparison which performance will be better, right? So there is the one condition is a mouse, and the other condition is the touchpad. So this one is the independent variable. So maybe we can say input device. Input device is your independent variable. Other example is you want to know the impact of avatar in virtual reality. So in the case, maybe you want to measure something, let's say just the presence. So which one will be provide a more immersive way when you have an avatar body and when you have a non-avatar body? So which one will be better? That is your research question. In this case, maybe the representation of the avatar body is your independent variables, right? And then what is the dependent variable then? Anyone?
Something that's dependent on various factors in your, it changes, it's changeable depending on.
Right. So which mean is a measurement, right? So for the first example, when we compare the mouse and the trackpad, then maybe the precision will be your dependent variables. For the second example, maybe the presence using the questionnaire, whatever, that is your dependent variables. So you always should have an independent variable and the dependent variables in your research design, right? So this is another example. So how many independent variables in this table? How many? Three? Three? There's two independent variables. Yep. Yep. Right. So we can say this one mouse, touch screen, and the hand gesture. Can you see that? Yeah, mouse. Okay. So this one is the label, but actually each attribute is the same, right? That is just the input devices, right? And then this one, maybe we can call distance, right? So distance and the input device is an independent variable in this table, but the input device has several labels. The level 1 is a mouse, level 2 is a touch screen, and the level 3 is a hand gesture. 1, 2, 3 is just literally I just represent the number. It doesn't have any value changes. The value is the same, okay? So maybe level A, level B, level C will be much proper. And then here's two levels, right? Level A is a close distance, level B is a far distance. So there's only two independent variables. But let me just change to this one. Then how many conditions we have? How many experimental conditions? 6 conditions. 1, 2, 3, 4, 5, 6, right? Okay, so typically we can have independent variables regarding the technology, the input devices or interface, and then design and the type of technology could be your independent variables. And the user also be your independent variables. If we want, for example, if your focus is a senior group, then maybe their age could be the independent variables. If you develop certain good devices for their education, then you want to prove the device. If this, let's say your research question is, I made this device, and this device will help more knowledge to the young people rather than older people, then the people's age will be your independent variables. And the context also can be your independent variables, so like environmental status, like the level of lighting, level of noise level, and the level of complexity in certain room. This room looks very complex because we have many people and many objects here. But if we remove all of them, then it will be empty, which is much simple. So in that case, the environment should be independent variables. So sometimes those independent variables can be designed by designer, but sometimes we can forget this kind of environment context can be independent variables. But if we couldn't consider carefully about that unexpected independent variables, then we can say that is a confounding. Confounding is always no good way for your experiment design. And then these are typical dependent variables. So efficiency can be task completion time, speed, and accuracies, which mean error rate and the success rate. and the subject satisfaction like using Likert scale, so like a presence questionnaire or other questionnaire as well. And then ease of running, the test score, running curve, retention rate, and the physical or cognitive demand, such as using the NASA task load index. So, for example, this kind of questionnaire is very well used when you develop certain devices, because when we're using certain devices, always it comes with a fatigue. So we want to know their level of the workload. When I'm using this trackpad, if I have a many workload, then maybe the interface is not so good, right? So in that case, we usually use this questionnaire. So also, we should think about other variables like controlled variables and the random variables and the confounding variables like that. Controllable variables, maybe in this case, we can assume this desk and this chair can be explicitly controllable variables, right? If you don't want to involve those objects in this room, then maybe you can just remove it, right? So explicitly, we can control all these kind of stuff, which is the controllable variables. And then what is the random variables? For example,
User's knowledge background.
yes. Who has a knowledge background?
The users.
Yeah, right. So user always be a random variable. We don't know. So sometimes we may provide certain task which require many energy, but some user didn't have a breakfast. But some user has some stomach error. So in this case, we don't actually expect certain errors. So this is a very problem actually. And then what is another one, which is a confounding variables. Maybe when you design your experiment, you may hear a lot of time about is this your confounding maybe? Or have you thought about this factor could be your confounding? Confounding is a really confound. So you should carefully think about it. If my research design has any confounding factor, then it will spoil your experiment design. Even you complete your experiment, but later you find some confounding, and which seems very significant, then you have to rerun your experiment. So this is a general step in user experiment. At the first time, always, we wanted to set up our research question first, which means we wanted to set up our hypothesis. After then, we wanted doing experimental procedure. And the participant will have different conditions. You will assign each independent variables. So depending on your experimental design, you may choose a subjective between subject test or within subject test or factorial subject test. And then during the time, you may want to control everything. So remove any expected confounding first. And then maybe for the random variable things, we can control its status. So which means we may need more samples. If you run with only 5 participants, then that will be problem. But if you run 500 participants, then you may have a more stable result, right? Which is good. And then during the time, carefully think about what measurement are we use. So if you don't sure why you're doing running your actual experiment, then good way is capturing everything. Okay, so just using your picture and capture video, and if you can capture physiological signal and then everything else. But actually this is a trade-off. each versus each complexity. So if you have a many complex level of measurement, then it will sometimes spoil or make a negative effect on your experiment design as well. So you should carefully think about it. How many complexity I can cover versus it is enough number of measurement. So you carefully think about your number of measurement. And then lastly, once we cover the statistic part, then we will use the something stat method on your collected data, and you will analyze the data, then you will report your answer. And absolutely, when you set up hypothesis, it should be testable, right? I have seen some hypothesis from your report. Then some hypothesis looks good, but it seems very hard to measure. In that case, you should just omit that hypothesis because there is maybe more high level of research question. There is not a hypothesis. So hypothesis should be always be testable, subjective way or objective way. So finally, your result should be answerable regarding your hypothesis. So let's talk about more hypothesis. What is the definition? The definition is a precise statement that can be directly tested through an empirical investigation. So the hypothesis, when we compare something theory, because a hypothesis is just a small question, so absolutely the size is compared to the theory is much smaller and more focused on a certain area. And the hypothesis can be examined by a single experiment. That's fine. And then we mentioned about that the hypothesis could be testable. And then hypothesis should be clearly defined. And then the scope have to be precisely, actually. It have to be appropriate level. And the hypothesis always includes independent variables and dependent variables. Actually, this is a very basic mention about the hypothesis, what is a hypothesis. But even though this is a fundamental way to think about hypothesis, but sometimes we just omit certain research factors. Some people just omit their independent variables, just to say, if we doing this one, then we will have a better performance. What is the better? What is the performance? And then for what? So we should always include the independent variables and dependent variables. So maybe this could be the good example when you're doing your hypothesis. The first example is for a pointing task, there is a significant difference in mean task completion time between the we and the Kinect. We and the Kinect is just device, okay? Then what is dependent variables?
The task combination task.
Great, yeah. And then what is independent variables?
Devices.
Right. And then what is the task? What is the task? Yeah, right, pointing. So very simple and very precise, and the scope is proper. So this is a really good example to making your hypothesis, right? And the second one is we shows significantly less error compared to Kinect when doing point task. So still independent variable is a device, right? And then the dependent variable is error rate maybe. And then the task is a still pointing task. So when we making some hypothesis, we may want to prove or disprove regarding your hypothesis. When you're doing your research experiment design, you may include multiple hypotheses, which is fine. But each hypothesis should be verified that is supported or unsupported. But you know, proving is actually impossible because we can't check every case. So alternative way is if we find at least one rejection case regarding certain hypothesis, then that is a much easier to disprove. Disprovement is a much easier way to support your hypothesis. Do you understand what I'm saying? Because we can find most all case in the world that is impossible. But if we find a certain at least one rejection case, which is a disprovement case, which is much easier to find to support your hypothesis. So generally, when you design your hypothesis, then we can say H1 or H0 or H1. That is just a conventional way. So H0 sometimes called null hypothesis, which means there is no difference. No difference is null hypothesis. And H1 is sometimes we call that alternative, which means there is a difference. That is simple, no difference or difference. We don't care how much, that's fine, okay? But at this moment, is there difference or is there no difference? So let's see this one. So let's see, for example, there is one hypothesis. The null hypothesis is there is no difference between the ease of use of ATMs with touch screen and ATM with buttons. So maybe the author wants to have a comparison. They want to just assume a bank wants to change the ATM machine. Currently, they just use a traditional way that is just a physical button, push there. But maybe one of the steps just suggests if we have a touch screen, then maybe it will make more easier to use for the customers. So they have just considering, is this true or not, right? So in this case, the alternative hypothesis is there's a difference. ATMs with touch screen are easier to use than ATMs with the buttons. Then we may just assume if this hypothesis is supported, then what will be our action? What will be the bank's action? Then they may want to change all their ATMs to the touch screen. And no difference. They will just remain there, right? But if we find this one is true, then what they will do? They will change their traditional ATMs to the new one, right? So in this case, we should think about the cost for their error, which called type 1 and type 2 error. Let's see. This one is much better. So just assume actually there's no difference. This is true, just assume this is true. There is no difference. But maybe some experiment doing something wrong way and then their experiment design was not so good. So their result was there's a difference. Then we call that as type 1 error. Okay? Which means the false positive. And then we just mentioned that as alpha, so sometimes we call this type of error like a type 1 error or alpha error. On the other hand, just assume this one. There's an actual difference. This is true, we just assume this one, okay? But because we had some wrong research design, so our result was there was no difference. This called type 2 error. And then there is a false negative. And then we also call this one beta error. Okay? Do you think which one is a much problem? Type 1 or type 2? Type 1, why?
Because if it's wrong, maybe we need to change the device.
A lot of cost, right? So the cost will be very high. So the conventional way is some researchers regard type 1 error is much significant. Have you seen this type of representation when you read some papers? Especially, have you seen this p-value? Yes. What is the p-value? What is the p? The p is a calculated probability. So usually we use a point 0.01. Then if p-value is less than 0.01, then we say that is a significant difference. There is something difference. And the reason is the type 1 error, we can calculate the type 1 error like 1 minus type 2 error, which makes sense, right? Because there is only 2 errors, type 1 or type 2. And then the 0.05 is adopted to control the occurrence of type 1 error, which means this one is indicate the type 1 error. And the reason why we choose a very small portion of the type 1 error means type 1 error is the cost of the type 1 error is much higher. For the reason, if we choose this one, then maybe we will be safe in a more stable zone. I will talk about this one maybe 3x later. Okay, so that's fine. Just I just wanted to give a simple idea. So which means this is just a probability. So if we calculate all the region, then the result is always 1, right? So which is 100%. But type 1 error means here is the only this small section. Actually, the section should be very small. So which means p is less than 0.01 means there is only small possibility that is a false, which is this small area. Unless we can believe that the result will be located somewhere in this area, which is much stable to say, right? So you will also use this type of representation in your research design at the end, right? And then this one is a type 1, and this is a type 2 error. So let's see some example. So what if there is a difference in pointing accuracy between V and just the movement and the kinect? And there is no difference in pointing accuracy between the 3 of them. I just solved that. So which one is a null hypothesis and which one is the alternative?
There's no difference is the null.
Yes, right. No difference is so the bottom one is a null hypothesis and the upper one is the alternative. So the goal of experiment is absolutely we wanted to find the statistical evidence, and we want using the result we may want to reject or support the hypothesis, right? Uh, you have to think about it. Statistics is just a kind of a chance, level of chance, right? So even though statistics say, okay, there is some chance p-value is less than 0.01, it doesn't mean 100%, right? We just we just rely on it's a high level of a chance. So already think about it. Uh, Before we mention about the random variable human, exactly. So because the random variable, we can control their status, and then maybe there is another factors which is a random variable while you're doing your experiment. So in this case, the only way is just to adopt many samples. Even though you adopt many samples, there is always an error will be existed in your samples, in your participant, or even if you running your experiment without participant, if you just running your experiment objective way, but still there is an error because computer is not a perfect machine actually, and sometimes its speed will be affected by unused resources like internet or like other resources. So there is already errors always be existed in your sample data. So we uh, carefully think about how many participants we can adopt. Actually, 500 participants is not easy, right? So when I running my experiment, the maximum number was around 50, but 50 makes me very tired, even 10. So that is very hard to uh, adopt many participants. And then maybe experiment yourself could be random variable because we are not a machine. So maybe sometimes I can treat that participant very politely, but after 10 hours later, I, I feel very tired, so maybe I will um, handle him very rude. Yes, you're doing this one. So maybe it will affect for your experiment. So we have to think about how we can well control about the errors. Error is always a risk for your experiment. For the region, we talked about that which one is more important, the type 1 error or type 2 error. That is the reason why we choose a p-value very so small, a small chance, 0.5. Sometimes, actually, we sometimes use a 0.1, 0.5, but some researchers sometimes adopt uh, zero point 0.1. But that is not a good way to get such a levelable probability level. And in the experimental research, generally we believe that type 1 error are much worse. There's a reason why we choose this one. And then let's come back to here. So in this case, let's think about it. The null hypothesis was there's no big difference in mean task completion time between the V and the Kinect. Just assume, okay? And then when after you running your experiment, you found that we had a 100 millisecond for the running time, and the Kinect had a 500 millisecond. So the difference was 40 millisecond. This is your result, okay? And then you thought that, okay, then maybe I can apply t-test. It doesn't matter, we don't know what is a t-test, just follow that way. So t-test shows that its difference was significant because the p-value was 0.4, which is less than 0.5. Okay, makes sense. But if we assume there's actually no difference, even though the t-test shows that there is a difference, but actually just assume actually there is no difference. Then what was the problem? What was the problem? What did he make error? Real? The problem was the sample. Yeah, right? And can you also find the other problem from this result? Before he analyzed his data, I'm not sure he or she, the person did an experiment, and the person got the data. V was 100 millisecond, Kinect was 500 millisecond difference. So the difference was 400 millisecond. What about the unit? 1 second is, right? This is 1 second. But millisecond is divided to 100. So, yeah, maybe even though there is some difference, but we can't ignore, right? So that was the problem for this hypothesis, the result and their analysis. So it says that we have to have a valid effective size for the sample, and then when you analyze your data, you should carefully think about the unit, or carefully think about the actual meaning of the values. Sometimes numerically there is some difference. We can see that, but even though we have some difference, but sometimes it just numerical changes, numerical difference. But its actual meaning for in reality, in real world, sometimes it doesn't have a meaning, right? Okay, let's talk about the experimental design. Do you have any question until now?
For the hypothesis,
Uh-huh.
like it has to be for the general topic or
Uh-huh.
for each research question. Like
Yeah.
we have to take individual hypothesis for each question, or we take like for a complete research topic.
Yeah.
It has to be for each question.
So that is actually depend on the situation, but generally we can have some research question with in a high level questions. So for example, I want to know if this device effectively conveyed some knowledge to the person who is an uneducated person or elder person or young people. So this is the high level question. Then after that, you may want to make some details. Then how I can support that research question with some hypothesis. So the hypothesis should be much clear, and then its scope should be much narrow, and then measurable, which means testable. So I will talk about your research topics in the next session. But I found that your research question, most of you guys' research question looks very interesting, but the problem is still including your hypothesis that is much broad. So you should clearly and carefully think about then what measurement I will use and then what will be my independent variables. Plus, it seems like you guys want to use VR technology. That is absolutely right. So that is the reason why you come to here. So think about it. Is this really, can I program this one? or can I implement this kind of devices? Can I convey my idea to actual product? So you should carefully think about it. While I read your paper, in my mind, maybe there is some ideas will have a good match with a PhD student. So maybe there will be really good resources for you guys, for in terms of implementation, in terms of designing experiment, which is really good. But some people, the idea looks still very nice, but it is a bit hard to find some good person to help you guys. So in the case, very carefully think about it, how I can implement the problem, the product, and then what will be the measurement, what will be the independent variables. Okay. All right. Let's take a 10-minute break, and then let's resume the lecture.
will allows you to learn how.
用起来，
用起来是没有区别的，人们觉得是它都差
He
不
say
多。
something about it doesn't
Very
know if you can prove it. It's just a yeah, it's just a yeah thing. So basically, whatever that you can money.
I think it's more of a creative project than a
Yeah.
Yeah.
它那个应该是 area 错误的判断错误的，
Yeah.
就是譬如说他取样的取错了，就是譬如说老人家对这两个东西都很严，
What?
No, no, no. We just
就
need to
觉得
like
没
processing.
You
difference。
don't
然后他们
have to. So yesterday I was looking at some sketches and
讲所有的这个都改变成3D，它这个成本，这个变
you
这个
don't
是
have
最高
to.
的。
No, you don't have to.
这个变这个成本是
You have to just play with it until you
没有3D 它就所以说
You
这个变这个是
play with the
那
colors.
个最不可观的东西，
That's a
不是
fact.
这么理
Like
解
the
的。
processing thing. Anyway,
yeah.
quite cool.
Yeah, it is.
So how much time do you play those?
2.
That's a goal.
所以说指定课是不是是编程？
When you have the meeting today?
What measure can be used? Can I program this?
With the last thing.
Right. Okay, let's talk about that. So the procedure is you may want to decide what is the independent and the dependent variables. Then finally, how many factors, how many conditions do you want to have? That is depend on the number of independent variables. And then if you want to run the multiple times with a multi-factor subject design, then maybe the number of conditions will be increases. And you should carefully think about what task and what environment will be involved in your experiment. And then the procedure also very important. I'm going to talk about that one. And the number of participants, and then how do you avoid bias or errors. What is the difference bias and errors? I'm going to talk about this one later. So independent variables and each condition, that is depend on the number of conditions, number of independent variables, and they depend on your study design. So you should think about how many independent variables you can use and how many different conditions for each independent variable, which means the level. Can you remember mouse, touchpad, and then hand gestures, something? That is all levels, but its attribute is the same, the input device, right? So that is just independent variables. And then you may choose like a 2x3 factorial design, something else. So in this case, maybe 2 and 3 is represent levels per each independent variables. So you may think about it, 2 is represent one level, represent one independent variable, and the 3 represent the other independent variables. If we have a 2 by 3 by 4, then maybe we will have another independent variables for represent another independent variables, but it has 4 levels, which is a very, very complicated experiment. I don't like that. So what is a between and within subject test? Have you heard about the between and within subject test? Okay, so that is a way how we learn actual study. For example, there's one factor we want to know. We want to know if this we call A. So we want to know how the A fast react much faster compared to the traditional one. So we want to test this one with maybe A group, and then we want to test the traditional one with a B group, right? So maybe it seems like this is very simple. If A group has a much fast result, then the code A device is much better compared to the traditional one, right? So in this case, we call this one is a between subject test. So A group always use A device, and the B group use always B device. What is the problem? What is the difficulties? Maybe it requires much number of participants, right? Because each participant, let's say, at least to know the effect size in stable way, then we could assume 15 to 20 participants will require per condition, which means the total will be 40, right? If we wanted to have one more comparison called C, then the total number will be 60, and then the number of participants will be increased. So there is a kind of a trade-off. So in this case, also we also want to know, we don't know their the previous background, previous experience regarding the type B, right? Because if I just compare to the Mac versus new type of computer, some participants will already had a experience regarding this computer, right? So we want to avoid a certain problem. So in this case, we may want to run within subject test, which means every participant will experience every devices, every condition, which is a within subject test. So as this diagram represented in the between subject test, each group only take each condition. And then we will just compare their result. Seems very simple and more clear, but it may have the other trade-off, like a number of participants, and then maybe we could avoid a certain bias, right? And then in this case, every participant will take every condition. So that is a within subject test. The problem, what will be the problem, maybe?
This will make you tired.
Yeah, right. That is one of a problem, and the other one is. Okay, then what is the advantage?
You have same background, educational background.
Right? Maybe we can avoid some bias, right? And then the other advantage is number of participants. We can reduce the number of participants. So we will talk about how actually numerically we can calculate the participant is called a power analysis. So I will have a lecture maybe 3 weeks or 4 weeks later. But the conventional way to making decision regarding participant is in between subject test per condition, we normally use 15 to 20 participants. This is just a conventional way, so some researchers will do different number. So that is not a stable way. And then for the within, per each condition, we usually put 10 to 15. That is a big difference. So maybe the number of participants will be one of the advantages for the within subject test. So let's see this one. So in the between subject test, we can avoid the interference effect each other. So each group always take care about only their conditions, so they don't interact each other. So which is good, which is advantage. And then each participant will have a shorter time, so maybe their fatigue level will be lower, as she mentioned. So which is good. And the impact of individual difference, so we can clearly see what is the exact difference between them, so which is also advantage. But it requires a large number of sample data, so large number of participants, which is a big problem. And then maybe we have to carefully think about their gender, ages, experience, because these can be biased for the experiment. On the other hand, the within subject, I'm going to talk about this one, and then it will take a longer time for the participant, which they will be tired very soon. And then the number of participants will be small, and then it is easy to detect the difference between the conditions as well. Then what is the learning effect? That is a major issue for within subject test. What is the learning impact? Let's say I want to have a comparison 3 computers, the A, B, C. I'm a participant, so I'm doing a computer, okay? This is good. And then I will do same task over the B computer, right? But actually I know what task I will do. So maybe I can do more faster, more accurately, or more easily to handle B computer. And the third, I'm getting more expert on that task. So that is much easier to do that. So this is a bias. So we call that as a learning impact. The learning impact will spoil your experimental result. So what will be the solution? I'm going to talk about the solution. Let's come back to here. So the learning effect will be aroused when I doing mouse first, touch screen first, hand gesture first, and then the B participant will also doing the mouse first, touch screen first, hand gesture first, and the C participant doing same way, mouse first, touch screen, and hand. This order makes a learning effect. Then the solution is mixed their order. So that's called Latin scale. So in this case, I made this order A, B, C, and then the B for the second experiment, I will have a B, C, A order, and the C participant will have a C, A, B order. So this is just a number of conditions, so we can expand it this way. But can you still see the problem maybe? What will be the problem? In terms of a learning impact. It still has some order. Can you find it? Yep. The B condition always followed with A, right? And then B condition always followed by A. If we adding more conditions, then we can see something order here, right? So we also want to certain order effect as well. So the solution is this one, which is called, I just forgot the name, something Latin scale, order some Latin scale, a balanced Latin scale as well there. Yeah, balanced Latin scale. The way is maybe we can do with this order. Let's say we have A, B, C, 6 conditions, A, B, C, D, E, F condition. Then we always start with the first 2. So A, B, and here is a N, and next one, D, and N minus 1, and the last one, F. Not this one. So this will be F, and then F minus 1, and C, and E, D, correct? Yeah, right. And then what will be the second one? Because we already spent this one, so let's think about the order is A, B, C, D, B, C, D, E, F, A. This is the order, and then we will reorder this one with a balanced Latin scale, which means BC is first here, so I just wrote BC here, right? No? Yep. BC, and then what will be the last one is A here, right? And then D and F, E, correct? Yeah, right. So in this case, that is not a perfect solution, but we can at least minimize the learning impact. Can you understand the way? So if we write actually that is not an equation, but I could say C, D, okay. A, B, N, C, N minus 1, D. But this A, B, C, D means it does not mean this one. It means each location. Location 1, location 2, location n, location 3, location n minus 1, location 4. Okay? Then can you understand? Yeah.
Shouldn't C be 4?
Which one?
Shouldn't N be location 3 and C be location 4?
Yeah, so the n is the last one. That because it depends on the number of conditions, so we can expand the condition. In this case, for example, we have only 6 conditions, but maybe we can expand it 7, 8, 9, 10, whatever. So this is only the last one, and then if we expand more conditions, A, B, C, D, E, F, G, H, we have 8 conditions. In this case, what will be the next? N minus 2.
Okay.
Yeah.
So that will be chosen, like, a number of conditions. What about we have 3 conditions?
Which one?
What about you have just 3 conditions? Because you didn't show
Uh-huh.
3 conditions there, just 4, starting from 4 conditions.
In here?
So you can use that with 3 conditions because there's always.
Okay, yeah, yeah. So 3 condition is, let's see, A, B, C. Then it always follows the A, B, right? So because the number, in this case, A, B.
Invalid for 3.
C. Yeah. Yeah, I think in this case, because that starts come with a 4, so when we doing the Latin balanced Latin scale, then it always begin with when we have at least 4 conditions. So when we doing the 3 condition, the other way is just using total random variable. So that would be the solution. So that is not a perfect way to avoid certain learning effect because the learning effect always happen. This is a numerically shows that it's a possibility how we can minimize the learning impact. But in reality, there's many ways to make a certain learning impact. So there is no perfect solution. But the solution, the possible solution would be just running some random variables. Randomly, you can assign some values to each participant if we have a certain small number of participants, right?
And those participants, they can speak each other. I mean,
That is a depend on your experiment design. But normally we just ask do not talk to each other, or there's a depend on the situation. So normally we can run experiments just one by one. So there's no chance to meet each other. But depends on your experiment. If you think about kind of a social thing, social means there is at least 2 people. So in this case, maybe they will have some chance to chat each other. So sometimes they can spoil their task each other. So if you don't want to do that, ask them, do not. Or you can make some perfect solution. Let's say just make some isolated environment. So put a participant in this room and then place other participant to other room. Such way. Right. Then, actually, I'm not sure this is the problem. We can say that is a problem or kind of an issue. But have you thought about something ish when we doing between subject test? Because the attribute of the between subject test is we wanted to compare. Okay, let's say if we have a 2x2 between subject test, which means we have a 2 independent variable, right? 2 by 2, which means there's a 2 independent variables. But actually, we want to know, let me see if we have a, okay, think about this and just ignore this part, okay? So we have a 2 by 2 experiment design, and we have a 2 independent variables, the distance and then input devices. Actually, we want to know if we get some result, then we want to say if somebody has a mouse and then close distance, and then they have a something, and then if they have a touch screen and the close distance, then they have a something, and then same so on. But actually, we don't. Actually, we don't know which independent variable caused some result. So there is some way to measuring. We call that is an interaction effect, which means each independent variable impacted to each other. So in this case, there is a mouse and a touch screen, but the participant, some participant was a novice, but some participant was experienced people. So in this case, maybe we can see some interaction effect. That is, sometimes there could be some bias, or sometimes we can say this is a confounding, but it is depend on the situation. But anyway, there is we have to check it out if there is an interaction effect was happened or not. I'm going to talk about this one later when we're doing statistical session, but we have to know there is some way to find a certain interaction effect. So once you've done your experiment, it may require to test the interaction effect. And then this shows that between subject and within subject test, there is the same things. And then balanced Latin scale and the factorial design. Then what is the factorial design? Factorial design means if you want to, some researchers want to run your experiment with a fully between subject test. In this case, you will have a 6 condition, right? So maybe you can assign people 20, 20, 20, 20, 20, 20. So 120 participants you will have. But you don't want to do that, so you may want to run your experiment as with a within subject test. So each participant will run every 6 conditions, right? You can reduce the time, but the participant seems like very tired. So their tiredness will affect to your result. So you don't want to have a certain effect. Then maybe the other solution is you can run your experiment with a between subject test, but include within, which means a participant will take this condition, but they will take this condition as a within. So a participant will have a condition, mouse with close distance, mouse with a far distance. And the other participant will run with this condition, touch screen with close, touch screen with far. And then C participant will have hand gesture plus close distance, hand gesture with a far distance. So each input device this independent variable can be run as a between subject, but this independent variable can be handled like a within subject. So this is the factorial design. Can you understand? Vice versa, if you think about it, if we want to make a more weight, or if some reason, maybe you can learn this one as a between and then learn this one as a within. So a participant will have a close with a mouse touch screen and hand gesture, and the B participant will only have a far distance with a mouse touch screen and hand gesture. So that is up to you, but you have to think about it. Then after then, how we can handling the learning impact, and how we can we can analyze the data, because that is a much complex compared to just a simple between, simple within, right? Okay. So we wanted to check it out the number of independent variables, and then please read this one. I will almost on a run website. So the number of independent variable is an important factor to design your experiment. And the number of participants is always an issue. So we're gonna talk about this one 3 or 4 weeks later. And then think about it, how we can handle error. So random error, sometimes we call that is just a noise. So noise is always happen. The human can be noise, and your environment also can be a noise. So that's fine. Fine means that is not okay, but there is no way to control all the noise. So there is no perfect solution. So we understand, okay, this is a noise. But we have to avoid certain bias. The bias can be happened by the learning impact, by the order, or maybe if you didn't think about their background, their education background, or their specialty, or their gender. Somehow there is a very sensitive data for your experiment design, so you should think about their expertise, their experience, or their ages, gender, whatever. So try to avoid bias. So there is 5 major sources for system errors. I will just read that one. Measurement instrument and the experiment procedure. So if your procedure didn't think about the order, that will make an error bias. And the sampling participant, if the number of participants is too low, or even though you have a very big participant, but if they all come from Canterbury University, or they all come from your family member, that is a bias, right? So we have to avoid a certain situation. And the experimental behavior, if I always handle participants very rude way, then maybe it will make another bias. And the experimental environment. If you run your experiment very noise area, like a construction area, they make a lot of noises, then it will impact very negatively to the participant, to the result. So for the region, last time we talked about the pilot testing. So I really strongly encourage you to have a pilot test with your family member, your friend, whatever, that's fine. So you can just see each tendency from the pilot study. Actually, we don't say pilot study, we call consultation. So consultation, so you can get some knowledge and some experience of what will be wrong and what have to be correct, what have to be revised. Okay, I'm talking about the usability very quickly. So usability is the same. So we can adopt observation, ethnograph, case study, interview, focus group, survey, questionnaire, and then some testing, because usability testing is just one of the example. So we can adopt a certain way. So there is not a matter. ISO, International Organization for Standardization, the group, they says that what is the usability is the extent to which a product can be used by specified user to achieve the specified goal with effectiveness, efficiency, and the satisfaction in a specified context of use. Can you see that specified? So for the reason, usability is not a scientific way. That is just improved its performance. The usability testing is focused on how we can improve. After we find something issue or something issue can be arised from the users, then we just want to focus on certain case. So that it is not hard to make generalized result. So for example, maybe we can have some thought about effective and efficient. Both the hammer maybe worked to put the nail on a rock, but what will be more effective? And then maybe both one will be effective, right? If you have a strong enough, then maybe even though you use a small hammer, then you can put the nail on the rock, so it will work. But if we think about efficient wise, then the bigger hammer will be maybe better, or vice versa, because it is much hard to targeting the nail. So safety issue will be aroused. So I'm not sure which will be the better. But clearly, this kind of stuff will not work, right? Yeah. So when you design the usability testing for your research, then you should think about it, learnability. How much easily we can learn. When you see this curve, maybe clearly I can learn, okay, grab here. I do not do this one, okay? So this is the learnability and the efficiency and the memorability, and then safety issue and the satisfaction, and the intuitive way is naturally can I understand what is this machine, what is these devices. This is one of the important factor, and the ergonomics. Ergonomics is did we consider about the human factor? Last time we talked about the human factor, including our sight, audio, and the smell, taste, and the tactile, right? So does this provide some ergonomics properties and the aesthetics? Yeah. So all these factors, we can consider about these factors when you design your usability testing. But interesting thing is that all these factors are sometimes contradict each other. If I made something looks very nice product, but somehow it makes very hard to run or natural way to, so what is this devices? So there is your trade-off topic. I'm gonna skip this one, skip this one, skip this one. There is one of example what is good to for your design usability testing. So the learnability, efficiency, and the error and safety issue, you should think about it when you design certain your product. Interesting thing is a number of participants is always important, but when we doing usability test, then there is some, this is not a theory, but one of the researchers suggests that if we have 5 users, in this case the user is an expert actually, then we can find approximately over 80% of problems. But this is a very ideal case. So some papers still adopt his result, but somehow it is very hard to apply this theory to certain environment, because there is if we have our usability testing environment is very simple, then maybe we can adopt this kind of stuff. But if we learn more complex usability testing, then we also need a number of participants. So this is the way how general way way for usability testing. So when in reality, when we doing usability testing, then we ask the participant to do certain task, and during the time, experimenter can observe their behavior and their objective measurement in a different room. Or we can use a video recording or take a photo. Even we can recording some depth images or depth tracking data. Yep. So usability testing is just one of the methods. So if we have another chance, I will talk about that one. But simply that's all. Because we don't have much time, I'm talking about this one. This one is your research topic, your title. So which seems very interesting. One student want to having some topic in virtual reality games, or I just read that one. Assistive technology for elderly people, which is good. The role of virtual reality technology in promoting tourism, which is also good. Applying augmented reality technology into interior design, very clear, so which is good. Virtual reality game, looks very interesting, but still bit vague, right? So in game for what? Do you want to make a more fun? Then what is the fun? Or do you want to make a more interactive way? Then how? Which devices you want to have a comparison? Because right now we have multiple input devices. We can use a keyboard or mouse or hand gesture or body gesture or even voice or eye track. So there is a lot of input devices. So if you want to having more research question in virtual reality game, then you should think about it very carefully. Which measurement, which independent variable do I need to pick? And the designing assistive technology device for children, which is a very similar topic with in the bottom, right? So they want to develop certain technology, assistive technology for the human. But the human, the scope is very narrow, which is good. One student wanted to focus on the adult group, one student wanted to focus on the very young people, but they have some different aspect, which is their intellectually disability. So which is the scope is very specified, so which is good. And then improving training performance and safety. Yeah, training performance and safety awareness in work organization. The student also trying to narrow down its scope, work organization, but maybe need more narrow down which work environment, outside, inside, and the officer, or something requires some physical demanding. So maybe need to narrow down its scope. With the intuitive instructional design and empathetic computer interaction in virtual reality and augmented reality. So the student wanted to adopt many high-end technology. But in this case, have to think about it. Virtual reality and augmented reality is very different. The uses is sometimes seems overlap, but actually that is very different, because in virtual reality, there is all thing is computer generated. But augmented reality is adding some computer generated data on a real world. So the situation is a big difference. So the reason why I talk about this one is I'm writing my feedback for your proposed research topics. So I will send it by this end of this week. So maybe you can get some idea. Because at this moment, the topic was a bit rough, and then still we have to develop ourselves. So maybe the feedback also a bit rough, and then because the reason is I want to try to you guys develop yourself. So I'm trying to avoid providing certain solution, but I will just point out some rough solution. Okay. Case study. So I will give a homework for this week, and the homework will be developing and summarize the certain paper. But the paper, when you're doing the summarize, then you have to include certain important factor. I don't want to talk about what is the important factor because we already covered. So when you're doing yourself, then think about it. What factor should be included in the summary? Okay, let's go. So this paper has been published 2010 in SIG-Chi, which is a really good venue. And then the title is Example-Centric Programming. That's fine if you don't understand each method, if you don't understand each science, the area, that's fine, okay? That's fine, I don't care about that. Example-centric programming, which is really good because when I read that title, I could imagine, okay, the scope is very narrow. He wants to reporting something for the programming. And then the other title is Integrating Web Search into the Development Environment. Okay, so this is not for general public, but only for the developers. And when they doing their actual program stuff. And then in the abstract, I could find that this paper proposed the embedding a task-specific search engine in the development environment, which is the same thing with the title, and it can significantly reduce the cost. That is their measurement. But still, I don't know what is the cost, right? But that's fine because this is just the abstract. Or finding information, and thus enable programmers to write better code more easily. I'm not sure what is the better code, but anyway, the author states that the programmers could do something better. And then a comparative laboratory study. So I could imagine this is an experimental study. He had something very controlled environment, and he learned their study. I'm not sure he did with a between, within, or even a factorial design, but that's fine. He did something in a very controlled environment. And the write significantly better, still don't know what is that. And the find example code significantly faster. I'm not sure, but he did something very fast, right? And analyzed over 3 months of usage log. So what was their measurement? Was the log data, right? So we can say that. So just for your understanding, I just quickly introduce what he did. So actually he was the one of a programmer in Adobe, the company. And then he found that while he doing something, because is there any programmer or any experience for the programming? Okay, so that's fine. When we're doing the program, but actually it is impossible. Maybe some guys possible, Adrian, but for me it is impossible to remember everything. So sometimes I have to search a website to get some example code. And then after I understand the example code, then maybe I can modify what I want to. But his way is, when I doing this one, when I open the web browser and then find some example, that takes the time. And it takes the more number of clicks and the more of typing, right? So he wanted to reduce the cost. When he doing his actual job, then in his browser, actually when I press the hotkey, then the browser will say the example code. Then I will just using my eye very quickly, I can look over and then choose the something example, and then using the way I can easily and then more robustly I can write my own code. This is his simple idea. Can you understand? So that's fine. And then this environment we called IDE, Integrated Development Environment. Yeah, IDE is not important, just for your understanding, okay? So let's go. So introduction part. So in the introduction, he introduced what is his motivation. When you say the left part, you can understand why he developed this work. What was his motivation? And he says that to learn a new technology, programmers will likely spend more time, perform several searches, and aggregate and compare information across the multiple sites, which means it takes time. It takes a cost, right? So that is one of the reasons. This paper investigate whether a task-specific search engine integrated into existing programming environment, which means his development, okay? His development can significantly reduce the cost of the searching for relevant information. So the reason why he invented this one is he just wanted to reduce the cost for the programmer. So that is a motivation, and then that is his research question, right? So he called his program as a blueprint. That is the program name, and he have two insight. What is his rationale? If he embeds the research engine into IDE, then maybe it will leverage the context, and then it will lower the cost of constructing a good query. Query is just a question, query is that one. When he writes some URL loader, there is a function, and then he wants to know how we can use the function, because each function requires some argument. So when he writes down the function URL loader, then press the hot button, then the URL loader will be sent to the server. That is a query, okay? And if we lower the cost, then it will finally improve the result quality. This is his one of the rationale. So why he thought about this way, okay? And the other rationale was extracting code and then compose it consistently, which means compatible, because we can't use every language, we can't use every program for every computer or every program. So that is we can say that is compatible. So he says that his program is compatible. Then if he made it compatible, then he can reduce the number of clicks, and then for the reason because he reduced the number of clicks, so the result will be rapid evaluation, which means rapidly the programmer can evaluate the code because he reduced the number of clicks, right? And then finally, they reduce the cost for selecting certain good example, which means in a traditional way, when programmers doing this one, then he have to go website, open the Chrome or Safari or something else, and then write down something, example code, what I want to, and then I have to check it out. This one is not so good, then I have to go the other one. Oh, this one is not so good. The other one, oh yeah, this is a good one. But he reduced all the procedure like this one. So that was his rationale, right? And then in his paper, he says that he did comparative laboratory study. That is a study one. And the other one is we released the blueprint online and logged its use. After 3 months, he took the 3 months time, and this one called study two. Okay, what he did open-ended interview question. So he had 2 studies. And then this one has 3 hypotheses. The first one was related to that one, and the second one related to second hypothesis, and the third one related to third hypothesis. Okay. So what was his research method? He had a controlled environment, and the total number of participants was 20, and 4 frequent users for the second study. And then what was the independent variables? Type of search and blueprint and the traditional one, right? This is the independent variable. What will be the dependent variable? He didn't mention here. So I will look at it there one. And what was the measurement? He used the log file and he did interview. And he made some 3 hypotheses, so please read that one. And this is just related work. So we don't care about relate work at this moment, but when you're doing your own research paper, relate work is a pretty important one, okay? And then he introduced how he implemented his system. So I just very quickly talk about that one. So this is the user side, and then this is the server, and then this is the Google search end. And then when user doing something and he wants to know the example about a certain function, then he press the hotkey, and then the query sent to the server, and the server use the Google search engine, and the Google will return the result to the server. And inside the server, something happened like this one. Okay, just ignore this part. And then doing something in the server with a database, and then finally the server will return the result to the user. That's fine. If we don't understand the procedure, that's fine. Okay, so in the result section, evaluation section, he mentioned about how he did for the first study. And then, as he mentioned, there was the fully controlled study, and he made 3 hypotheses. This hypothesis is much more specified, which is really good, okay? And then regarding faster, what does it mean? Then his hypothesis was programming using Blueprint with complete directed task. We don't know what is a directed task, but he will mention about it later, so that's fine. More quickly than compared to the traditional one. And what does it mean better code? It's a high quality as code. And then what does it mean the better code again? Better design on exploratory design task. So still there's a bit vague, but he explained more details in the later, so that's fine. And then what is his method? He ran his experiment with the experts. So this is expert-driven experiment. And then what is the treatment condition? That is a blueprint. And the control group is a traditional one. In his paper, he says that the control group used the Firefox and the Adobe Community Help Search Engine. That is a different one. That is just traditional one. And for the blueprint users, they do not allow to use a web browser. The treatment group always have to use a blueprint. But when I read his research method, he didn't clearly mention if this experiment was a within subject or between subject. But when I read this one, I found that, okay, this is a between subject test. This is a bit not a good way. So when you're doing your actual experiment, just clearly mention we did within subject or between subject or factorial design we did, so which is important. And he used the subjective measures. Experts just measured about the code quality. So okay, now I understand what he means about the higher quality. So that is just a subjective measure. And the result, they says that actually they didn't provide this kind of a table, but I just summarized the table, so which is much easier to understand the final result. So blueprint, when participants doing the first time, then they took 57 seconds versus traditional one takes 121 seconds, so which is has a big difference. And when he ran statistics, then the p-value was less than 0.01, which is a significant difference. But when they actually finished all the tasks, even though there is some time difference, but the p-value was not significant difference. And then he mentioned he did another study. This is not a second study. This is within a first study. and he did something explanatory task, which is also subjective measure. And then this is the second study. And then what is the second study? Second study, the type of second study is longitudinal study, which is takes a long time, right? And they use the logs as well, and then use the interview. And then in the second study, he also mentioned 3 specified hypotheses here, which is really important, right? And then the keyword was benefit of consistent and the symbiotic, which means compatible, and clarity and the remind. So if this program remind the programmer easily or something else, so he mentioned everything there. And this was the methodology for the second study. And then I also made the result here. The interesting thing is how he made a number of participants. Because blueprint user is explicitly defined, right? But how we can define the actual number of participants for general users, for traditional users. So he just randomly choose 5% of random user. So the 2024 is the number of participants for the blueprint, and then 13,283 was the number of participants for the traditional user. And then he used the actual log file from those participants. It was 17,012 log queries come from the blueprint, and then 26,036 queries come from the traditional users. And then there was the result. And then each result supports each hypothesis like that, which is really good. And then he also conducted the other study that is within the study 2, which called explorative analysis. That is just a kind of subjective measure, but this is just an interview with the expert. Because they also wanted to provide more high-level insight to the developers. So please read this one, and then this is the discussion section. And in the conclusion, he clearly mentioned that to support programming by example modification, he developed this system. And then they found that significantly faster than with traditional web search tool. And then because he also mentioned his implication why this was happen. So this is the description about the assignment 2. I will post this on our own website so you can find it maybe this afternoon. And I will provide that paper. Actually, the interesting thing is that the paper is the previous paper of this paper. So maybe you can get some connection even though the order is the opposite way. And then I'm going to ask you to have a paper review and summarize the paper up to 3 pages. And then your work should be, you have to do by yourself, okay? And then there is a grading criteria. So I would expect to have a completeness and the clarity and the conciseness. So if, because this is a summarized paper, so you don't need to make some verbose way. So just very clearly and simple. But it have to involve every research factor. So for example, what is the independent variable? What is the dependent variable? What is the result? And then what is the research question? What is the hypothesis? What is their method? There is many things we already covered. So think about it and then put everything, but simple. So if you want, you can use a Word file, but I encourage you to help. Give me a second. to help. Latex. So I'm gonna give you this example file to you, and then you can create your own overlap account here. That is free, so you can go to here. Okay, I'm gonna log out. And then you can register here, then you will have a free account. So that's fine. So if you want, and then actually I very strongly encourage you to use a latex format. So I will post this one on the website as well. So if you want, you can use this one, just copy and paste this one. After then, if you just type everything, okay. Come on. Really? Can't tell about it. Yeah. Thanks. Okay, I'm gonna type something here. After that, compile. Then you see that? Yeah, that is easy. So okay, and then if you're doing, if you're working on a Word file, then just follow this way. So maybe it is very hard to follow this format. Just trying to make this format. Okay. Yep. Any question? The due is next Wednesday.
Because this weekend we have a field trip from Friday to Sunday.
Friday to Sunday.
Yeah, we outside.
All of them? All of you?
All of the 4 of us.
Okay. Then. Okay, next Wednesday is the 13th, but what about 15th, Friday? Is it okay? Okay, so next Friday. Okay. Okay, I'll post it.
That's okay, man.
I think you just finished this.
All right, thank you.